All right, today we are taking on angle relationships. And first, I'm just going to refresh you on some vocab that I'm assuming that we have heard before. So, an acute angle is an angle that has a measure that is less than 90 degrees. Okay, a right angle, we often see this sweet little box notation that means that it's a right angle, which is exactly 90 degrees. So we have an angle that is exactly 90 degrees. Okay, an obtuse angle, we have an angle that is more than 90, but also less than 180 degrees. A straight angle is really just like a straight line. It is exactly 180 degrees. Okay, and then a reflex angle, I just wanted to point this out to you. We're not doing that much with it. So a reflex angle, we might look at this and say, well, that just looks acute, right? That looks like an acute angle, but that's not the angle I'm talking about. I'm talking about this one right here. Okay, so if I'm looking at this angle, that's an acute angle, and this would be a reflex angle. So this angle is more than 180, but less than 360 degrees. Okay, so starting off with some vocab. Okay, next we're going to use a protractor. So we should all have a better protractor than the one that I'm going to use to model with. You should have a small one that looks kind of similar to this one, but should be not a transparency. This is what I had at home as I was making this video, so it's going to get the job done. I just want to show you a protractor. It has two scales. So it has two scales that start with the 0. So for my protractor here, I have my top scale, which goes 0 up to 180, and then my bottom scale here is 0 up to 180. So I'm saying use the protractor, find the measure of angle CAT, and then classify it. So what I do is I take my protractor. Right here is the center of it. So I want to line it up where that is right there on the vertex of the angle. So I'm looking at angle A. So I'm trying to align it perfectly so that the ray right here, AC, is lining up with this part of my protractor. Okay, and again, my vertex should be right here. That's where the center of the protractor is as well. So I have it aligned like this. So that means I'm using the scale that starts at 0 and reading up to where it intersects. So if I just adjust ever so slightly like that, and I read 0 all the way up to where it crosses, that looks like 75 degrees. Okay, if I had rotated my protractor and did it like this instead, let me show you what that would look like. So about like this. So here's the center of the protractor. I'm making sure that that pathway, that ray, runs through the 0 degrees, and then I'm reading that bottom scale up to where it crosses through, still 75 degrees. Okay, so my measure of CAT is 75 degrees. And if I classify it, that is an acute angle. Okay, and then I'm saying, well, can we go in reverse? So can we use a protractor to draw an angle with a measure of 108 degrees? So I would start with drawing a ray. Doesn't matter which way you draw it. If you want to do it the same way I'm going to do it, let's draw it to the right. So I'm going to make a ray like that. So here's my endpoint. Here's my arrow. Okay, so then I'm going to take my protractor and I'm going to align it like so. So here is the center of the protractor. There was the endpoint of the ray. And I'm making sure it slices through at that 0 degree. And then I'm going to read from 0 up to 108. So if I go all the way up to where 108 is, it's putting me right here. So I'm making a little dot right there. Make sure you can see that. There's my little dot at 108 degrees. I know it's obtuse, so it has to be more than the 90. So let me pull that. And then I can connect through that pathway like so. So here is my angle of 108, but I want to make sure that I'm labeling all of my features. So if I call it FOX, well, O has to be here because that's my vertex. That's the letter in the middle, so O is the vertex. And then F and X, it really doesn't matter where I put the F and the X. So I'll put the F here and the X here, but if I flip that, no problem. That actually does not matter. Okay, next up, we're looking at the angle congruence postulate. So we saw this with segments as well. Postulate is a very basic, obvious idea statement that we accept as true without any sort of formal proof. So angle congruence postulate, here I usually just draw this little picture just to summarize it. So if our angles are congruent, their measures will be equal. If angles have equal measures, they will be congruent. So if I write this out in words, we're saying, okay, well, if angles are congruent, then their measures are equal. Okay, and then the flip side, if angles have equal measures, then they are congruent. Okay, so if angles are congruent, then their measures are equal. If angles have equal measures, then they are congruent. And just to summarize notation, if I am talking about the angle itself, I would use, for example, angle BAT. So that's talking about the figure itself, the angle itself. And when I switch and I talk about its measure, I tuck a little m out in front of it. So I would say the measure of angle BAT. So angle BAT, its measure would be that little sweet baby m out in front, measure of angle BAT. Okay, so now use the angle congruence postulate to complete. So if the measure of rat is equal to the measure of pig, well, if their measures are equivalent, then the angles must be congruent. So angle RAT, angle rat, is congruent to angle PIG, angle pig. Okay, and then if I reverse that, if these two angles are congruent, then their measures must be equal. So the measure of rat must equal the measure of pig. I like to use words. Okay, another postulate, we saw this show up with segments as well, the angle addition postulate. So the angle addition postulate is telling us that really smaller parts, they add up to a larger whole. So let me write that first. So parts add up to a larger whole. So for example, let's say that I told you that that angle has a measure of, say, 20 degrees. This angle has a measure of 30 degrees. Then this whole angle right here would have a measure of 50 degrees. So we know that the measure of angle CBR, so this angle right here is the CBR. If I add that to the measure right here, RBA, that will make up the whole thing right here, the measure of CBA. So these two smaller parts add up to this larger whole. That's just like what I said, 20 plus 30 equals 50. So pretty intuitive. Anytime we see a postulate, it's meant to be pretty obvious. It's a basic, obvious statement that we accept as true. We don't need formal proof to back it up. All right, so here's an example using the angle addition postulate. So in the figure, we're told that the measure of CBR is 2x minus 11. So right here, 2x minus 11. Okay, RBA, so this measure here is 3x plus 14. Okay, and then CBA is 103. CBA is the entire thing, and that's 103. Okay, so we know that the angle addition postulate says, well, these smaller parts, they add up to this larger whole. Okay, and right now we know that this part is the 2x minus 11, and this part is the 3x plus 14, and then this part is 103 degrees, all in degrees. Okay, so parts add up to a larger whole, so I can say that these two add together and equal 103. So I can say that 2x minus 11 plus 3x plus 14 equals 103. Okay, and now I just have a linear equation to solve. 2x plus 3x is 5x. Negative 11 plus 14 is 3 equals 103. Take away 3. 5x equals 100. Divide by 5. And x equals 20. Okay, so I'm good there. So then I just have to write the 20 right here and then plug back in. So if I plug the 20 in for this smaller angle, CBR, 2 times 20 is 40, and then minus 11 is 29. Okay, RBA here, 3 times 20 is 60, plus 14 is 74. Okay, and I always just want to double check. I want to make sure I didn't do any bad math. Is 29 plus 74, does that take us back to 103? Absolutely, it does. We are good. All right, flip to that second page. I have it right here. So next, we're going to go over some special angle pairs. And by using that word pair, the implication is that we're looking at two. A pair of things means two. So we're looking at two angles. So let me first write that. Pairs means two. Okay. Complementary angles. So complementary angles have measures that add to 90 degrees. So we're looking at two angles with measures that add to 90. Let me give you a couple examples. So I could have a right angle to start, like so, that I have a ray that divides it into two smaller parts. So those two angles, they would be complementary. I could say that one angle is the complement of the other. Okay, but another way I could draw it, they don't have to be connected like this. I could draw an angle that looks like this, and an angle that looks like this. Let's say that this angle is 43 degrees and this one is 47. Right, those two angles would add up to 90 degrees. Their measures would add to 90 degrees. So those are also complementary angles. One angle is the complement of the other. Together they add up to 90 degrees. Okay, another special angle pair that we see are supplementary angles. So a pair of angles whose measures add to 180. So for example, we could start with a straight angle. So straight angle like this that has a ray coming off of it like so, that splits it into two smaller parts. So those angles would be supplementary. Together their measures add to 180. One angle would be the supplement of the other. Okay, but they don't have to be attached. They could be detached and look like this. Say this angle here is 65 degrees, and this one is 115. So again, their measures just have to add to 180. They can be attached or detached. So a good way to remember these two. Complementary starts with a C. Supplementary starts with an S. So C comes before S alphabetically, just like 90 comes before 180 numerically. So complementary, those measures add to 90. Supplementary, those measures add to 180. Okay, next up we have linear pairs. So linear pairs is essentially just a straight angle that's being split into two smaller angles. So straight angle that splits into two smaller angles. So I have to have some sort of straight angle like that that's being subdivided by that ray into two smaller parts. So linear pairs are always supplementary. They always have to add up to 180, and they have to share this common side right here. So let me add that note. So linear pairs are always supplementary. Which means that they add up to 180. Okay, so linear pairs are always supplementary. They always start with that straight angle that gets subdivided into two smaller parts. So linear pairs are always supplementary. They always add up to 180. But the same would not be true in reverse. We have supplementary angles that do not form linear pairs, and that would look like this example right here. Okay, next up we're looking at vertical angles. So I'm going to draw it first. So I have these intersecting lines like so. And your vertical angles would be the angles that are in opposite positions when two lines cross. So here and here, for example, those would be vertical angles. So angles in opposite positions when two lines cross. Okay, I can show notation that they're congruent with this little arc notation. I could also use a tick mark like that. Those vertical angles are congruent. Okay, so vertical angles are angles in opposite positions when two lines cross, and vertical angles are congruent. Okay, next up. Example 5. Use the visual below to name all special angle pairs. So first we're looking at complementary angles. So take a moment and see if you can find them. So complementary angle pairs, we know that they have to add to 90 degrees. So I'll tuck that right here, 90 degrees. Take a moment and see if you can find them. There's two pairs. Okay, first pair would be these two. So angle A and angle B, those are complementary. A is the complement of B, or B is the complement of A. Okay, another complementary angle pair would come from here, from that right angle that is being subdivided into two smaller angles, and these happen to be congruent. I can see that tick mark notation, which actually tells me that they both would have to be then 45 degrees. So these two angles, they are congruent and they're complementary. So GHJ and JHI would be ways to name those angles. So we're talking about GHJ and JHI. So I'm using that three-letter notation so there's no confusion. Okay, supplementary angles next, right? They add to 180. So supplementary, they can be attached or detached. So my first pair, take a moment, see if you can find them. So we should identify these right here, B and C first. Those angles are supplementary. B is the supplement of C, or C is the supplement of B. Okay, we also have another pair. So if I look here and here, those are both right angles. So 90 plus 90 would be 180. So I could say angle DEF and angle GHI, using that three-letter notation. And then over here I have another visual. Anything that's a linear pair would always be supplementary too. So angle 1 and 2, angle 2 and 3, angle 3 and 4, angle 4 and 1, those would all be supplementary as well. So let me add that. And all linear pairs. So 1 and 2, 2 and 3, 3 and 4, 4 and 1. So we have a lot of supplementary angle pairs in this visual. Okay, so next the linear pairs. So remember that has to be a straight angle that is split into two smaller angles. So always 180 as well, but they have to share that common side. And we've already listed them. We know that it's 1 and 2, 2 and 3, 3 and 4, and 4 and 1. Okay, and then lastly, vertical angles. We know that they are congruent. They're in the opposite position. So that would be 1 and 3. Those would be vertical angles. 4 and 2. Those would also be vertical angles. Okay. Next, the supplement of an angle is 4 times the angle measure. Find the measure of the angle and its supplement. So I'm going to look at the angle and its supplement. Okay, so the supplement of an angle is 4 times the angle measure. So I'm defining the supplement in terms of the angle. So the angle measure is my x, that's my unknown. And my supplement is 4 times the angle, so 4 times x right here. Since the angles are supplementary, then I also know that they have to add up to 180 degrees. Supplementary angles always sum to 180. So I've defined my angle, I've defined the supplement, and again together they have to add to 180. So I can build an equation. X plus 4x equals 180. Okay, combine those like terms. So 5x equals 180. Divide by 5. And I get that x is 36. So the angle itself is 36 degrees. And its supplement 4 times 36 is 144. And again, I'm just going to quickly double check. Does that add back up to 180? It absolutely does, so I know that I've done my job. Last example. Okay, so here we're asked to solve for x. We're solving for the measure of x, y, w, and w, y, z. Okay, and we're given a visual. We see that right angle, and we see these two smaller angles here and here. So we know that these angles are complementary. We know that that means that they sum to 90. So I can build an equation where I'm saying 1 1/4. I'm just going to write that as an improper fraction. So 5/4 4x minus 10 plus 3/4 of x plus 20 equals 90. Okay, I've built my equation. My two smaller parts add up to that larger whole, which is 90 degrees. I see a lot of fractions. I'm not a fan of fractions. So I would clear my fractions by multiplying every term by 4. What I do to one, I have to do to all of them to maintain the balance of my equation. So 4 times 5/4 is 5. So I have 5x. 4 times negative 10 is 40. So I have 5x minus 40 right now. 4 times 3/4 is 3. So 3x right here. 4 times 20 is 80. And on the right-hand side, I have 360. So 5x minus 40 plus 3x plus 80 equals 360. Combine the like terms. So 5x plus 3x is 8x. Negative 40 plus 80 is 40. All equal to 360. Take away that 40 from each side. So 8x equals 320. And then divide by 8. And x equals 40. All right, I got to x. X is 40. So now plug that back in. So if I take here, if I take 5/4 of 40 and then take away 10, let me write that out in a different color. So I'm taking 5/4 of 40 and then I'm going to take away 10. So 5/4 of 40, so if I'm multiplying these fractions here, I can always reduce top down or on the diagonals. So that 4 and 40 could go to a 1 and 10 here. So I get 50 minus 10, which is 40 degrees. So this would be 40 degrees. Okay, and then if I take 3/4, let me just find a different color here. So if I take 3/4 of 40, again, 40 over 1, just like that, and then add 20, I know that 4 and the 40 can go to 1 and 10. I have 30 plus 20, which gets me 50. So 50 degrees right here for the measure of WYZ. And again, just double checking, does it get me back to 90? Oh, yes, it does. Absolutely, we are good. All right, that's all I have for today. Have a good rest of your day.